So I'm going to be going over 8th grade problem number 22, and the problem is Parth and Andy are both running 100 laps around the track. Parth runs every lap that is multiple of 3 in 6 minutes, but otherwise he runs laps in 8 minutes. On the other hand, Andy runs every lap with an odd number of divisors in 5 minutes, but otherwise he runs laps in 9 minutes. When Parth finishes, what lap is Andy on? So for this problem, the first thing we want to do is find the total time it takes Parth and the total time it takes Andy to run the 100 laps. Once we have this information, it's going to be much easier to calculate what lap Andy is on. So let's start with Parth. He runs every lap that is a multiple of 3 in 6 minutes, and otherwise he runs laps in 8 minutes. So what this tells us is that if we determine the number of multiples of 3 from 1 to 100, then we'll be able to compute the total time it takes Parth to finish the 100 laps. So starting with that, we want to find the multiples of 3 from 1 to 100. And we can list them out as 3, 6, 9, 12, 15, all the way to the biggest multiple of 3, which is less than 100, which is 99. And to calculate the total number of numbers in this list, we can factor it as 3 times 1, 6 as 3 times 2, 9 as 3 times 3, 12 as 3 times 4, and so on until 99, which is 3 times 33. And just by looking at the pattern here, 1, 2, 3, 4, 33, we note that there's 33 multiples of 3. So now that we have this information, we can calculate the time it takes Parth, because we know that he runs 33 laps in 6 minutes, and he runs the remaining laps in 8 minutes. And if we calculate this out, we should get an answer of 734 minutes. So now we're going to move on to Andy. He runs every lap with an odd number of divisors in 5 minutes, but he runs all the other laps in 9 minutes. So similar to Parth, which was multiples of 3, now we want to find the number of numbers from 1 to 100 with an odd number of divisors. And we actually find that every number with an odd number of divisors is a square number. So to see this, one way to look at it, let's take an example of n equals 36. We see that the divisors come in pairs that multiply to 36. So for example, 1 is paired with 36. 2 would be paired with 18, 3 with 12, 4 with 9, but then 6 would be paired with itself because of course 36 is a square number because 36 equals 6 squared. So in general, what we see here is that every divisor, except if the number is a square number, like in this case, would be paired with another number distinct from itself. So 1 is paired with 36, 2 with 18, and so on. So in these pairs, there's going to be 2 divisors. So if we take the number of pairs and multiply by 2 to count the number of divisors, that would give an even number of divisors, unless if we have a square number in this case, because 6 is paired with itself. So we're not going to count that as another plus 2. Instead, we're going to count that as plus 1 because 6 is paired with itself. So that's kind of the way to see that every square number has an odd number of divisors, and every number with an odd number of divisors has to be a square as well, conversely. And there's a more rigorous way to prove this, but that is the more intuitive explanation of it. So if we want to find the square numbers from 1 to 100, we list them out as 1, 4, 9, 16, and these are values that you should have memorized, all the way to 100. And we can count the number of square numbers in this list by doing a similar thing to up here. We can express this as 1 squared, 2 squared, 3 squared, all the way to 10 squared. And following the pattern here, we see that there's 10 square numbers. So we do a similar calculation for Andy as 10 laps, which take 5 minutes, plus 100 minus 10 laps, which take 9 minutes, for a total of 860 minutes. So from here, there's a couple different approaches you can take to find what lap Andy is on. And the first one, which is a lot harder, is to note that Parth finishes in 734 minutes. So at the 734th minute mark, what lap is Andy on? And to find that, we can sort of guess. So similar to here where we calculated the time it takes for Andy to run 100 laps, we can do the same thing for example, 50 laps, 60 laps, 70 laps, and we keep on narrowing our search down depending on how close we are to 734 minutes, and we want to find a number of laps that is close, that will take a close amount of time to this, and we can kind of pinpoint our answer from there. But that's going to take a lot of time and a lot of effort because we notice that 734 is really close to 860. So what this means is that Andy has already run a significant amount of laps. So if we're going to try to do this calculation, we're going to have to take a big number of laps, perhaps like 80 or 90, and guess from there. And that's not a lot of fun. So we want to take another approach. And the way to do this is look at it from the back. So what this means is that we want to look at the time Andy has left to run, which is 860 minus 734, which is 126 minutes. So he has 126 minutes left to run. And we kind of want to count backwards. So how many laps is it going to take for counting from the back to be close to 126? And this will give a close answer for what lap Andy is on. And to formalize this solution, we want to define a couple of terms. So first off, let's define f of k to be the time it takes Andy to run the last k laps. And on the other hand, let's say that Andy is on the nth lap counting from the back. So what counting from the back means is that let's say that he's on the 96th lap counting from the front. So what lap does that correspond to counting from the back? So 100, 99, 98, 97, 96. So it would be the 5th lap counting from the back. So that's kind of the notation I'm going to use. And we want to relate the value of n and the function f of k somehow to 126 minutes, which is the time it takes he has left to run. So since he is on the nth lap, f of n minus 1, which is the time it takes to run the last n minus 1 laps, that's going to have to be less than 126. Because, of course, the time it takes to run that last n minus 1 laps is going to have to be less than it, because Andy still has a bit to run left on the nth lap. And similarly, 126 is going to be less than f of n, because Andy has already run part of the nth lap. So he has 126 minutes left to run, has to be less than the time it takes to n laps because he has already run part of it. So from here, we want to find a value of n such as this equation is true. And to do that, let's start counting from the back. So the 100th lap is going to take 5 minutes. The 99th lap is going to take 9 minutes. 98th lap is going to take 9 minutes. And we can keep adding until we get 126. But to make this calculation faster, we note that for values that aren't square numbers, so it would just be 100's a square number, and the next square number counting from the back is 81. So if the numbers are from the range 82 to 99, we note that they're all going to be 9. So on this range, we know that there's never going to be any 5s that appear, so we're always going to sum 9s. So in this case, it would be 5 plus n plus 9 times n minus 1 if we're counting for f of n. And we want this to be greater than 126. And if we solve for n here, we're going to get that 9n is greater than 130, which means n is greater than 14 and 4/9, expressing it as a mixed number. And since n is an integer, that means n is greater than or equal to 15. From here, we note that since we're trying to find the number such that f of n minus 1 is less than 126, we're going to want to find the smallest number n such that f of n is greater than 126, because that's the only way f of n minus 1 is going to be less than 126. So we're just going to take n equals 15. So this is the number of laps counting from the back. But what is that converted to the number counting from the front? So looking back at our example here, 96 became 5, and the way we did that was we took 100 minus 96 and added 1 effectively. So doing the same, we can say k is the number we're looking for, plus 1 equals 15. And solving that gives k equals 86. And this is going to be our final answer, 86 laps. Thank you for listening.